We're continuing working through the AB Fall Review FRQ packet. So this is number 4. A ball is thrown straight up in the air from a point 64 feet above ground level so that its position is h of t is equal to negative 16t squared plus 48t plus 64, where t is measured in seconds. Use this to answer the following. The ball is actually being thrown off of a point that's 64 feet above ground. Okay, so technically this should not be here. This ball is going to continue past this point. Okay, so I know that eventually this problem is going to work its way down to finding the acceleration. So I'm going to go ahead and just find the derivatives that I need. So if I start off with position, then one derivative down will take me down to velocity. So negative 16t squared becomes negative 32t plus 48. And then a of t is simply going to be negative 32. Okay. Part A, what's the height of the ball at 2 seconds? So if we plug 2 into the position function, then I can find out the position or the height of the ball. So plug 2 in for the t values and simplify, we get 96 feet. So the ball is going to be 96 feet above ground 2 seconds after the ball is thrown. Okay, what's the velocity at t equals 2? Okay, so velocity, we can simply plug 2 into the velocity function, so negative 32 times 2 plus 48. The velocity is going to be negative 16 feet per second. Okay. Part C, part C, when does the ball reach the highest height or the greatest height? So we know the ball is going to reach its highest point. We'll reach the highest point when the velocity is going to reach 0, right? And so what we can do is we can set velocity equal to 0, find out the time that it occurs to reach that point. Okay, so we're going to take velocity function, set that equal to 0. When we do that, we can solve for t. So negative 48 over negative 32 is 3/2. So that means 1.5 seconds in, the ball will reach its highest point. Okay, part D, what is the greatest height? Okay, so we know that the ball is going to reach its greatest height at 3/2 seconds. So if I want to find out the position at this moment in time, we can plug 3/2 into the height function, right, or the position function. So plug 3/2 in for the height function. So negative 16 times 3/2 squared. 3/2 squared is 9/4, plus 48 times 3/2 plus 64, and that simplifies, reduces to be 100 feet. So the ball will reach its highest point 3/2 seconds into after the ball is thrown, and the maximum height is going to be 100 feet. Okay, part E, at what time is the ball falling at a speed of 48 feet per second? Now, we want to, if it's falling at a speed of 48 feet per second, that means the velocity must be negative 48, right? Because velocity has direction and negative. If the ball is falling, then we can consider that as velocity decreasing. Okay. So what we need to do is we want to find the time when the velocity is negative 48, so we can set v of t equal to negative 48 and figure out the time when that occurs. So here's our velocity function, negative 32t plus 48. We set that equal to the target velocity that we're after, negative 48, and then we can solve for t. So subtract 48, divide by negative 32, and we get 3 seconds. So 3 seconds into the problem, the ball will have the exact velocity of negative 48 feet per second. Okay, part F, at what time does the ball hit the ground? Okay, so this is talking about position, right? So the ball is going to hit the ground when the position is at 0. So what we can do is we can set our position function equal to 0 and figure out at what t value is this particular position going to, or height, going to occur, height of 0. So this requires some factoring. So if I factor out negative 16, I get t squared minus 3t minus 4. And this factors out to be t minus 4, t plus 1. The negative 16 just goes away, divide by negative 16. I'm just really solving for t. So t equals 4 and t equals negative 1. Now we're dealing with ball is being thrown after when t is greater than or equal to 0. So negative 1 is not going to be used. Just going to be t equals 4 seconds. Okay, part G. With what velocity does the ball hit the ground? Okay. So we know the ball is going to hit the ground at t equals 4 seconds. So we want to find out what is the velocity at this moment in time. So we can plug 4 into the velocity function. So the velocity of function is negative 32t plus 48. So plug 4 in for t. Negative 32 times 4 plus 48 will be negative 80. Now we're talking about velocity, so the unit of measure is going to be feet per second. Okay. What is the ball's average velocity? Okay, so again, we've got to be careful with this word average because it's not the same thing as instantaneous. Okay, so average velocity is simply the change in position over change in time. So we're not going to use the velocity function. We're going to use the position function and find the slope between the endpoints. Okay, so h of 2 and h of 0. H of 2 is 96, h of 0 is 64. So the change in position is h of 2 minus h of 0, 96 minus 64. Change in time is going to be 2 minus 0. Simplify that, we get 32 over 2, which is 16 feet per second. Okay. What is the ball's acceleration at t equals 2 seconds? So acceleration, we want to find instantaneous acceleration, so we can plug 2 into the acceleration function, but there's no variable to plug in, so it's just going to be a constant negative 32 feet per second, or negative 32 feet per second squared. Okay. Part J is the speed increasing or decreasing. Okay, so if we want to determine whether the speed is increasing or decreasing, we have to compare the signs between velocity and acceleration. Okay, so the velocity at 2 seconds is negative 16 feet per second. Acceleration at 2 seconds is negative 32 feet per second squared. So notice that the signs are the same. So because velocity and acceleration have same signs, speed is increasing at that moment in time at t equals 2 seconds.